Right, this is what some people think is one of the more trickier parts of the electricity unit in the National 5 physics course. It's called voltage dividers, or voltage division, but if you know what voltage is, then it's relatively straightforward. Remember, voltage is a measure of the energy that's transferred by the charges as they move around the circuit. We've got a 12 volt battery here. So that means these charges that come out the battery have to deliver 12 joules of energy as they go around the circuit. Now there's two resistors in this circuit. So that means that 12 joules has to be delivered to these two resistors. They're in the same path, so they get a share of that energy. They share the 12 joules carried by each coulomb of charge. They share that voltage. Now, if both resistors are the same, how much of a share do you think they get of that 12 volts each? Well, let's measure it. That one's 6 volts, and that one's 6 volts. In other words, any charges that come out the battery carrying 12 joules will deliver 6 joules to this one and 6 joules to this one. Now, doesn't matter. If those two resistors are the same, doesn't matter what size they are. If I change this, let's make this 15, and let's make this 15. Right? If both resistors are the same, then they get an equal share of the voltage. But the tricky thing is, what happens if the resistors are different? Let's put this one back down to 10 ohms. And let's make this one 20 ohms. So this one's got twice the resistance. That means that the charges will have to use twice the energy to get through there as they do through this one. So what do you think the voltage will be if the coulombs give out twice the energy to this one? Remember, 12 joules when they come out, so this one will get, what do you think? 8 volts. So 8 joules is transferred by each coulomb as it goes through there. And this one must get 4 volts. Right, so let's have a wee look at this on paper. Here's our circuit drawn with a 12 volt power supply, 12 volt battery, and let's put those two resistors on. Remember, these two resistors are sharing that voltage, so two 10 ohm resistors, those two resistors are the same, so each one will get 6 volts. And no matter what those resistors are, if they're both the same, then they will get an equal share of the voltage. So if that one was 20 ohms and R2 was 20 ohms, then again they both get an equal share of the voltage. The voltage is divided equally across both of them. Now, where it gets tricky is what happens if one resistor is bigger than the other resistor? What happens if this resistor is 20 ohms but R2 is 10 ohms? R1 is twice as big as R2, so it will get twice the voltage that R2 gets. Similarly, if R1 is 30 ohms, it's 3 times bigger than R2, so it will get 3 times the share of the voltage, 9 and 3. Now, is there an equation that allows us to do this? Because what happens if those numbers are not easy to split up, like 30 ohms and 20 ohms? How do we work out what V1 and V2 are? Well, let's see what they are. That one's 7.2 volts, and this one is 4.8 volts. 7.2 and 4.8. Is there an equation? Yes, there is, and it's on your relationship sheet. Here it's here. V1 divided by V2 is always the same as R1 divided by R2. So again, if we go back to a simpler example, 20 over 10 is 2, 8 over 4 is 2. The ratio of the resistors is the same as the ratio of the voltages. 30 over 10 is 3, 9 over 3 is 3. The ratio is 3 to 1. That relationship is on your relationship sheet. Now, let's go back to our difficult example. If we have 30 ohms and 20 ohms, how do we work out those voltages V1 and V2? Can't do it using this relationship. But what we can do is we can use the total voltage and the total resistance. So our total voltage was 12 and our total resistance is 30 plus 20 is 50 ohms. So if we want to figure out how much of a share of the voltage each resistor gets, we have to think about how much of the total resistance each resistor has. So R1 is 30 out of 50 ohms. So it will get 30 50ths of the total voltage. And 30 50ths of 12, if you do that in your calculator, is 7.2 volts. The second resistor is 20 out of a total of 50 ohms. So it will get 20 50ths of the voltage. That's 4.8 volts. Let's build this circuit and see if we get the same result. So there's our 30 ohm resistor, 7.2 volts. And our 20 ohm resistor should be 4.8 volts. And the two of them added together gives us 12 volts. So, is there a general equation we could use for working out? Well, let's think about V2. V2 is resistor 2's value divided by the total resistance. That's the two of them added together, times the supply voltage. It's exactly what we did to work out the voltage that each of them got. So that is the general equation for working out how much of a share of the voltage a resistor will get in a voltage divider circuit. That relationship is on your relationship sheet, and it will work for any voltage divider circuit that's got two resistors in it. Here's another one, even trickier. 36 ohms and 14 ohms. If we want to work out V1 and V2, pick whichever one you want. Let's start with V2. So if it's V2, we have to put R2 at the top. Now, what voltage will that be? It will get 14 out of the total resistance, which is 50. So it will get 14 50ths of the 12 volts. Do that in your calculator and you get 3.36 volts. Now we could repeat that for V1, for the voltage across resistor 1. Now you could of course just do 12 minus 3.36, that would give you the answer. Or we'll do it the long way. V1 will be equal to the resistor's value, 36, divided by the total. So 36 50ths of 12 is 8.64 volts. Notice the bigger the resistor is, the more of the share of the voltage it gets. And the two of them added together, 8.64 plus 3.36, is 12 volts. It's always good to check this, so let's go back to the FET website. There's the same two resistors, 8.64, and this one should be 3.36. Okay, you can try that yourself. Try building some voltage divider circuits. Guess what the voltage should be or work out what the voltage should be and then check if you're correct. Now, voltage dividers are at the heart of electronic circuits that contain sensors, and we're going to be studying them in more detail later. But the difference is, voltage dividers in electronic circuits are shown sideways. Circuits turn through 90 degrees, but it's exactly the same. It's two resistors that are sharing the supply voltage. So we've got a 12 volt supply here. The battery's not shown, but they're telling you it's 12 volts and the two resistors are 120 ohms and 30 ohms. How much voltage would each of them get? Well, you use your voltage divider equation. Remember, this relationship is on your equation sheet. You don't need to remember it. So it's resistor 1 divided by the total of the two of them added together, that's 150, times the battery voltage, which gives us 9.6 volts. It's quite a large share of the voltage it gets because it's a large resistor. V2 is equal to the 30 ohm resistor over the total of the two of them times the 12 volts. So, doing the working, 30 divided by the two of them added together is 150 times 12, and doing that in your calculator is 2.4 volts. Now you could of course just have done 12 minus 9.6 and got the same answer. Either way, you have divided up the voltage. And as a wee check, you should always check that those two voltages add up to the supply voltage. So, looks like quite a tricky equation to use. It's on your relationship sheet, so just know where it is and where to use it. Let's just check this one as well. Let's build it very, very quickly, just to show you that those were the correct voltages that we were using. So here's a voltage divider. It's built sideways. These two resistors are the same, so we should expect them both to get the same voltage. They should both be getting 6 volts. So the bottom one gets 6 volts and the top one gets 6 volts. But let's just check the example that we just did there, where we made the top resistor 120 ohms. So let's slide this all the way up. And the bottom resistor was 30 ohms. Remember, you can try this yourself on the FET website. Make these resistor values whatever values you want. Now, let's bring our voltmeter in. The top voltage should be 9.6. There it is. And the bottom one should be 2.4 volts. That's voltage dividers. Let's go and try a few questions.